why so many Chrome users encounter certificate errors in the wild and what we can do about it. So the subject of this talk is this error page, which many of you may have encountered yourself before and been very angry about. This is the error page that Chrome shows when it's trying to set up an HTTPS connection, but the HTTPS connection fails because Chrome can't validate the certificate that the server sent. So when we began this project, we knew a few things about these error pages already. We know that they're a pretty bad user experience. This is just sort of from common sense. When users are using the web, going about their business, trying to get stuff done, and they encounter one of these errors, it's going to be a bad experience. They can't do what they wanted to do on the web. We also know this from a ton of posts on our Chrome product help forum, where these certificate errors are a top source of complaints, and we see posts like this all the time with users who have encountered these errors and don't know what they mean and don't know what to do about them. We also know from Chrome telemetry that these errors are way too common. We show hundreds of millions of them in Chrome every month. And it just sort of stands to reason that those wouldn't all be attacks. It's just too many. So we suspected, as many of you might suspect, that these errors are being shown due to misconfigurations or other sort of benign problems, not merely attacks. In other words, a large number of these certificate errors have got to be false positives. And put together, that's basically a recipe for warning fatigue. We're showing these errors all the time. We're showing them in non-attack scenarios, which means we're training users to sort of click through them, ignore them, figure out how to work around them. And so if a user ever encounters one of these errors in an actual attack scenario, how are they supposed to differentiate that from the gazillions of times they've encountered this error before when it didn't turn out to be an actual attack and nothing bad happened to them when they ignored the error? So the questions that we were looking at in this project are, why are we showing so many of these unnecessary certificate errors in the wild? Why are these false positives happening? And once we understand that, is there something we can do to get rid of them or improve the experience so we sort of lessen this warning fatigue impact? To investigate these questions, we started by adding this checkbox to the certificate error page. Users can check this checkbox to opt into uploading a report when they encounter one of these errors. So once a user has checked this checkbox, when they encounter a certificate error, a report is sent to some Google servers which contains some details about the incident. Things like the site that the user was trying to access, the certificate chain that they saw, the local system time, the certificate error that was encountered. Some details like that that help us figure out what actually caused the certificate error to occur. We send these reports through an analysis pipeline that we built that applies a bunch of heuristics to try to automatically label each report with a root cause. Basically, the thing that caused the certificate error to occur, usually a misconfiguration that needs to be fixed somewhere. We also did a whole bunch of manual review on these reports, and we did that for a few reasons. One was to sort of inform how we should build this analysis pipeline. So we sort of looked manually at reports to figure out what are the root causes we should be looking for and how do we come up with heuristics to label those. Also to validate the results of our analysis pipeline once we had built it and run it. Those are some of the things we did to look for manual review. There are also some errors that we couldn't automatically classify that we investigated just by looking at reports ourselves, which I'll talk about a little later on. So this pipeline is able to automatically classify about 2/3 of reports with a root cause label. And of those automatically assigned labels, we see that about half of reports are caused by client or network problems, and half are caused by server problems. And this sort of overall pattern holds up when we look at manual review also. So the key takeaway of this talk is that when you think of certificate errors, you might think, as we did, of expired certificates, self-signed certs, other sorts of server-side misconfigurations, but those aren't actually the biggest culprit in this story. Clients and networks are as much to blame as servers for false positive certificate errors. That's the sad part of the story. The happy part is that there are many things we can do client-side to sort of work around or fix certificate errors, often making it so that users don't even need to see a certificate error that's caused by misconfiguration. So in the latter half of the talk, I'll give some examples of features that we built into Chrome to sort of lessen the impact of false positive certificate errors. So today I'm not going to go into too much detail about how our analysis pipeline works and what are the heuristics that we apply and the details of all the possible root causes we look for a particular report. All those details are in the paper, and today I'm just going to give you kind of a highlight reel of the worst things that happen on the client and the network and the server that cause unnecessary certificate errors. And then at the end of the talk, I'll give some examples of these mitigations we built, features that we built into Chrome to improve the situation rather than just understanding it. Starting at the client-side misconfigurations that cause certificate errors are an interesting category because there's really one thing that sticks out like a sore thumb, and that's bad system clocks. So incorrect system clocks are sort of the worst in terms of client-side causes of certificate errors. On Chrome for Windows, incorrect client clocks account for about a third of all certificate errors that we show. So this is basically the single biggest category of root cause for certificate errors on Chrome for Windows. And even though this problem is biggest on Windows, it's nothing to sneeze at on other platforms too. So as you can see on Mac and Android, it's about 8 to 9% of certificate errors, which is also really big. Just in case it's not clear what this even means, what does an incorrect system clock have to do with a certificate error? An HTTPS certificate comes with a validity period, a date before and after which the certificate's not considered valid, and if the time falls outside that validity range, then the user will see a certificate error. So that means if the user's clock is set incorrectly, such that it falls outside this validity range, the user will see a certificate error even if the certificate is actually valid. So the server is doing everything right, serving the correct valid certificate that's valid according to true time, but when evaluated against the client's incorrect clock, the certificate will appear to be invalid. We don't know too much about why client clocks are so horrifically bad. We have some theories, things like malware, users intentionally changing their clocks because they're cheating at games or they're trying to get around software license restrictions. Some of it is almost certainly due to hardware issues like a dying CMOS battery. But basically, we don't know which of these reasons or something else entirely is mostly to blame for all these bad clocks. We do know that when a certificate error is caused by a bad clock, it's almost always a clock that's in the past and almost always within 3 months of true time. So we're not seeing a whole lot of errors caused by clocks that are decades behind. It's more like days or weeks. There are a couple other client-side causes of certificate errors, things like misconfigured antivirus programs or corrupted root stores, but really client clocks are the thing that stuck out, and it was kind of silly to focus on anything else when misconfigured clocks are such a big problem. And at the end of the talk, I'll give you a little bit of detail about what we decided to do about that problem. Moving along the spectrum of where certificate errors can be caused, the next source of errors is the network. And the two biggest problems that cause certificate errors on the network are captive portals and TLS proxies. Captive portals are those Wi-Fi networks like at airports or coffee shops or the Sheraton Hotel, if you're staying there, where you connect to the Wi-Fi network and then you have to, all your traffic to the public internet gets black holed until you log in or authenticate in some way with the network. So if you've encountered a certificate error yourself, it may very well have been in a captive portal where you connected to a Wi-Fi network and then you went to some HTTPS site and you got a certificate error. And errors of this type with this cause are about 1 to 6% of errors in Chrome, varying depending on the platform. And for reasons I'll discuss in just a second, we think this is a pretty conservative underestimate. So this is really a lower bound. It's pretty big. Like, this is well in the range of what we care about. If we could knock out 1 to 6% of certificate errors, we would be very happy. But we think it's actually a lot more than this. So let me explain how this whole captive portal certificate error thing happens. The user goes into their favorite coffee shop and connects to the Wi-Fi network, and then opens up their browser and types the URL of a website like google.com. The connection goes to Google. The client attempts to set up a connection with google.com, but the coffee shop Wi-Fi redirects that connection to the coffee shop login server because the user hasn't authenticated yet, so the user's not allowed to talk to the public internet yet. If this were a normal HTTP request and there were no HTTPS in the picture, this would work just fine. The coffee shop login server would redirect the user to a login page where they'd authenticate, and then everything would work. But when this is an HTTPS connection, there's a TLS handshake going on. And this TLS handshake has been redirected to another server, which returns a certificate for coffeeshoplogin.com, not google.com. So from the client's perspective, it's asked for one website and gotten a certificate that's valid for a completely different website, so this results in a certificate error. And why we think these certificate errors are undercounted in our data set is because this redirection of traffic away from the intended destination applies to our certificate reports also. So we only receive a subset of certificate errors that are caused by captive portals because many of them are just going to be kind of swallowed by the captive portal itself. The other thing that just wreaks havoc on networks is TLS proxies, in many ways, though I'm just going to talk about one specific way. When you have a TLS proxy that's in use, it generally works as a sort of typical TLS man in the middle, using a root certificate that is supposed to be installed on the end user device. But if that certificate isn't installed on the device, that causes a certificate error, and that accounts for about 7% of all certificate errors in Chrome for Windows. We think that it's probably Windows, primarily Windows problem, likely because of the prevalence of Windows devices on corporate networks, where a lot of these problems tend to occur. And we think this is also likely kind of a lower bound or underestimate because in this case, the way that our heuristic works is very conservative and just looks for a known list of vendors. So anything outside of that vendor that causes such as that list of vendors won't be included in this count. So the way these proxy-induced errors tend to happen is that you'll be behind a middle box, typically something like a content filter or an enterprise firewall, something that wants to inspect or tamper with traffic on its network. So when you're on a network like this and you go to connect to google.com, the middle box intercepts the connection and sets up its own connection with the real google.com, which returns the real google.com certificate, which the middle box hopefully validates, but doesn't return to the client because it wants to intercept the connection. It uses a certificate that it mints. So it has its own google.com certificate that it mints with its own root certificate. And if the client accepts that certificate, then data will be encrypted between the client and the middle box and between the middle box and google.com, allowing the middle box to read and tamper with traffic. But the problem, of course, arises when the client doesn't have that root certificate installed. If the client doesn't have that middle box root certificate, then the client's going to see, the user is going to see a certificate error because from the client's perspective, this is just a fake certificate for google.com. So together, captive portals and TLS proxies are a pretty big chunk of certificate errors. And as I said, we think both of them are undercounted. So in my opinion, these network misconfigurations are really the biggest dumpster fire of certificate errors. And they're also they tend to be somewhat frustrating errors because users are not always in control of the network that they're using. They don't administer the network. They don't know what root certificate to install or how to install it. So they're kind of errors that are outside the user's control or purview to fix. finally, we arrive at the server. And as I said, when we started this project, we really thought the server was going to be the source of most of these misconfigurations. We thought that servers were going to be serving expired certificates and self-signed certificates, and those were going to be the real problems that caused all of these false positive certificate errors to occur. But it turned out that's not the case. As I said, clients and networks are just as big a culprit. But further, there's one particular problem one particular type of server misconfiguration, which was not at all what we saw coming as a predominant cause of certificate errors, and that's a problem called missing intermediates. So this problem is 36% of all certificate errors on Chrome for Android. And I will explain why this is Android specifically, but this is, this is huge. This is kind of akin to bad client clocks on Windows. This is like, it's not even worth focusing on anything else until we fix this. So there's two kind of facts that need to be explained to understand this problem of missing intermediates. First, Chrome uses the operating system for certificate validation. So if Chrome on Android is validating a certificate, it goes and asks Android, is this certificate valid? If it's on Windows, it'll go ask the Windows API, is this certificate valid? The other thing is that we're not talking about just validating a single certificate when you're setting up an HTTPS connection. You have the certificate, which is the Leaf certificate, the website certificate, and that's signed by an intermediate certificate, which might be signed by another intermediate certificate, and so on, until we get to an intermediate certificate, which is signed by a root certificate that is in the operating system's trust store. So this entire chain must be built in order to validate a certificate. And the server is supposed to provide that chain. The server is supposed to send the Leaf certificate and any intermediates that are necessary to build this chain. Now, of course, servers don't always do what they're supposed to do. And many servers don't send the full chain that they're supposed to send. And that's okay on most platforms. On most platforms, Chrome will say, hey, is this certificate valid? And if the certificate doesn't come with the necessary intermediate certificates, then the operating system, in the process of validating the chain, will actually go and fetch the intermediates that it needs. I said on most platforms, it doesn't do that on Android. And that means that all these sites are serving incomplete chains that validate just fine in Chrome for any other platform, but result in a certificate error on Chrome for Android. There are a number of ways that servers can get this wrong. They can send just a single certificate. They can send a subset of the intermediates that are needed, but not the full set. They can send the wrong intermediates. But it turns out most of the time when an error is caused by one of these incomplete chains, it's just because the server is sending a single Leaf certificate. So that sort of suggests that site operators might not even really know that they're supposed to be sending intermediate certificates at all. Now, there are other server misconfigurations that cause certificate errors. All the sort of typical culprits like expired certs and self-signed certs, but those aren't huge slices of the pie of certificate errors. And so rather than go into those, I'm just going to give a quick characterization of the types of sites that tend to be misconfigured in ways that cause certificate errors. So to do this, we took the worst offenders. What we did is we took all the reports that are pipeline labeled as caused by server misconfigurations, and we grouped those by domain name, and then we took the top 100 domain names. And then we manually categorized those into the categories that you see here and a few others. This is just the top 5. So as you can see, this just sucks a lot. Government sites are disproportionately responsible for causing certificate errors. And I just find this so depressing because usually when a user is going to use a government site, they're doing something important, like paying their taxes or trying to find out how to vote. And that is not a situation in which we want users to be encountering certificate errors. So to me, this just sort of motivates the whole problem space. Like, these certificate errors aren't happening for users who are reading celebrity gossip or fooling around with their home routers. These are happening for real people trying to do actually very important things. Okay, so the first 3/4 of this talk was the depressing 3/4. I'm now going to try to tell a slightly happier story about what we did to try to improve the situation, lower the incidence of these generic false positive security warnings to hopefully reduce the chance of warning fatigue from all these unnecessary certificate errors. From Chrome's perspective, we have this hierarchy of approaches we'd like to take. When there's a certificate error caused by a misconfiguration, ideally we'd be able to work around it in some way and just not show the user an error at all. If that's not possible, the next best thing is to show kind of an actionable error UI that ideally helps the user figure out how to fix the problem and make the error go away, or at least sort of set them down a path where they might be able to figure out how to do that. The worst option is to show this generic security warning that just says your connection is not private and we don't know what to do about it and you might be being attacked. Of course, the challenge here is that we don't want to make an attacker's life easier. We don't want to incentivize an attacker to disguise their attack as a misconfiguration. If we could just silently work around all errors by just not showing certificate errors, but that would obviously not be a very good idea because that would make an attacker's life much easier. So I'm going to just give, in the interest of time, just a couple quick examples of this second category, the next best category of how we customize error UI when we can detect that an error is caused by misconfiguration. This error page is now what Chrome shows when it can detect that a certificate error occurred because of a bad client clock. So you can see instead of telling the user, hey, you might be under attack, we're saying you need to fix your clock and actually point them to the place where they can do that. To do this, to implement this, we built a secure time service which detects almost all errors caused by bad client clocks. So almost always when a user encounters a certificate error because their clock is wrong, they see this customized UI that helps them fix the problem. And we measured that users are pretty likely to actually fix their, well, relatively likely to fix their clock when they see this error UI. So about half the time that we show it, the user actually fixes their clock before the error page is dismissed. So that's not great. One could hope it would be higher, but that compares to about 3 or 4% for the generic security warning. So we're doing a lot better with this warning and actually getting users to fix problems. This is a sneak preview of a new feature. This has not hit Chrome stable yet, but this is our approach to try to deal with the problem of missing routes for TLS proxies. So what's going on here is that we took the top vendors of TLS proxies from our data set, and when we encounter a certificate error that looks like it was caused by one of those proxies, we show this error UI to sort of hint to the user that there is something on their computer or network that is causing this problem, and they need to either talk to a network administrator, try disabling some proxy settings or the program, etc. So this hasn't rolled out to stable yet. It'll be interesting to see how and if it works when it does. You'll notice in both this and the previous error UI, we removed the option to click through the error. And we did that to, as I said, avoid giving an incentive to the attacker to disguise their attack as one of these misconfigurations. So because the user doesn't have any ability to click through the error when they're seeing one of these error pages, there's no incentive for the attacker to try to trigger this error page in the course of their attack. Overall, not just these that I've shown here, but a whole bunch of mitigations that we describe in the paper, we think these have improved or removed about 25% of all certificate errors in Chrome. So that's pretty good. We're pretty happy with that, but there are some things we're still thinking about. So I just thought I'd end with a few of the open problems that we're still trying to tackle. Things like, how do we detect captive portals reliably? This is a hard problem, and it doesn't just apply to Chrome, it applies to operating systems which themselves also try to do captive portal detection. We'd like to encourage better TLS proxying practices because this problem of false positive certificate errors is not the only security problem that arises from TLS proxies. And finally, we're thinking about how to get site operators to fix errors, because as we saw, many servers that users use to do important things on the internet are serving invalid certificates that are contributing to this problem of warning fatigue. So these are just some of the things we're thinking about as we continue on our quest to rid the world of certificate errors. Thank you.
All right. So if everyone would state their name and affiliation before the question.
Okay. Yeah. Hi, I'm Meng from Stony Brook University. I have a question related to certificate check process because I feel in like Android system, the computing power will be very limited. So will be like even for example, it will be it will take like it will be less frequently for the system to update the rules. So if that is the case, I mean, like comparing to the desktop platforms. So if that is the case, will be like will it be some problems behind? Like for example, if there is some malicious website. Or maybe like some certificate error with some famous website, and it will be like a delay for users on the Android systems to really like be warned of this problem.
Just to make sure I understand, that was the question: how big a problem is outdated root stores?
The first question is that the case that the Android system will take maybe like less frequently to update their root alias? Is that the case?
I'm not sure. I think Android root stores do tend to be fairly out of date, but I'm not sure if that's because users are not taking updates or because they're actually because updates aren't being pushed to them.
Okay. Yeah. Okay, sure. Okay.
I really enjoy the work. Daphne Yao from Virginia Tech. I just have a related question, which is somewhat generic. I feel like I have fewer certificate errors when I use my phone. I just want to hear your thoughts on, is it because it's the phone's layout, the UI that prevents the certificate from showing up, or and then more deep reason behind it?
That's somewhat surprising to me. You use an Android phone, it looks like?
Android and also iPhone.
iPhone, okay. Yeah, I don't know why that would be. I mean, it wouldn't be anything about the UI. If you're using Chrome on Android or Chrome on Android versus Chrome on desktop, there shouldn't be anything about the UI or device size or anything like that that would impact the incidence of certificate errors. It might just be the types of sites that you tend to browse on one or the other. I'm not sure.
So Brian Parno, Carnegie Mellon. For the issues with the client clocks, you mentioned that you do have access to a secure time. So couldn't you bypass the errors directly, or is it because you're relying on the operating system to do the checks?
Yeah, so that's a great question. We do have sort of in our roadmap, like using the secure time for certificate verification itself. We can't currently because we use the operating system, and not all OS APIs let you kind of stub in your own time. But it is on Chrome's roadmap to switch to our own certificate validation library, and certainly when we do that, we'd be able to just use the secure timestamp directly for validation.
Cool. Thank you.